All right, for example 2, same thing, polynomial inequality. First thing we'll do is we will, as I mentioned, make sure you get everything over to one side because we need to be comparing a polynomial function, oops, that should be a minus, polynomial function to 0. So I'm going to subtract the 3x squared over, that should be a minus there, and subtracting the 9x as well, and then the 27. So now we've got our polynomial compared to 0. So 4 terms, if we're trying to break this thing down, we can try factoring, and we've talked about the number pattern of 1 and -3 compared to -9 and 27. That looks promising for a number pattern that will work with grouping. So x cubed minus 3x squared is one group, always plus. -9x plus 27 is another group. And remember, when we're breaking this thing down, we're ignoring this. We're forgetting that for now. We're just working with the actual polynomial. And so x squared as a GCF factored out leaves us with that. Here I'll pull out a -9, and that will then reduce that down to an x minus 3, and that's what we needed to see. We needed to see that common, what I call the big GCF there, and that means that can now be factored out of x minus 3, and our leftovers of x squared minus 9. Now we're not done because we don't have linear factors yet. We're going to keep breaking things down, specifically this x squared minus 9, which happens to be a difference of squares that would break down to x plus 3 and x minus 3. We still had this factor originally of x minus 3, so very important to point out, this breaks down to x minus 3 squared and an x plus 3, right? 2 factors of that and 1 factor of that. So from there, our 2 zeros come from x minus 3 equals 0 and x plus 3 equals 0, so 3 and -3. But very importantly, and we'll note it right now, this 0 came from a factor with multiplicity 1, right? Multiplicity 1, whereas this factor of x equals 3 as a 0 had multiplicity 2. So remember, that means here for the multiplicity 2, we expect a bounce behavior. Multiplicity 1, we expect it to cross. That'll be very important. Now, when we go to put our number line up here, basic number line, the only 2 important values, as we saw, were -3 and +3. Do make sure you always put them in the right order, obviously. Now, before we put those circles on, we go back up to the question and we ask, what kind of inequality were we solving? The less than will be important here in a moment, but what's very important is that there is no or equal to here. We do not want the points on the x-axis where this value would be equal to 0. So that is what tells us to put open circles on both of those values of x. We do not want to include those numbers. Now, beyond that, we can start to fill in the signs of what's happening here. We'll start that by determining end behavior. So the end behavior of this function, right, once it's in this form, was x cubed, right? X cubed is odd, and notice the number out front of it is a positive one, so positive. And so we said we use the reference of just our x cubed function. For any odd degreed polynomial, we know the end behavior is what it would have been if it was x cubed. And x cubed had that shape to it, so the falling to the left, rising to the right end behavior. So we know that whatever this is has to follow that same end behavior. So on our number line, far left here, it's definitely falling, far right, it's rising. And now we'll go through and see what the sign is doing from left to right. Falling to the left means, again, it's negative for all of these numbers until you get to here. Now, it hits this point, hits -3. Here's where you want to go check. At -3, multiplicity of 1, it's supposed to cross here, right? So it's going to cross from negative to positive. So it will be a positive. It'll be above the x-axis past that point. Positive for all of this, getting to here. This value of 3 as a 0 came from that factor that had a multiplicity of 2. So it bounces. Bouncing is the same as saying keep the same sign, right? If you're up here above the x-axis and then you bounce back up top. You bounce upward again, so you're still above the x-axis, and that makes sense because that's where we had to be. We had to be able to be rising to the right. Again, I mentioned you can sketch things if you want. If you want to, you can totally talk about the behavior of that function looking like that. Starting low, crossing, bouncing, ending high. There you go. That aligns with our negatives and our positives. But now, with this number line in information about signs, we go back and now finally say, what do we want? We want less than 0. That's all we want. We want what values of x will make this function less than 0. Less than 0 meaning negative y values. So, of all of this, the only thing that actually makes our function negative are values of x left of negative 3, right? These values over here. So, from negative infinity all the way up to negative 3, but we didn't want to include it, right? There's no or equal to. We do not want negative 3 included in our answer. So, there's our interval.